Today we're going to talk about graphing radical functions. So the first thing that I want to do is show you what the square root general form is. And it's going to look familiar to you. So y equals a times square root of x minus h plus k. So hopefully this a and h and k are all familiar. Let's think about what k does. K and h and a, they perform the same functions no matter what the parent is, or they have the same jobs no matter what the function is. So k, of course, is the vertical shift. H is a horizontal shift. And A is a vertical stretch or compression. And so those letters, the numbers that get in place of those letters, is the same no matter what the function is, just like we learned earlier in the year. Okay, so let's talk about just the general parent y equals the square root of x. So here are the 4 points that you need to have on your square root of x graph. So when x is 0, of course if you put in 0, you get y is 0. If x is 1, y is 1. Now you might be thinking x is 2, but if I put a 2 in here for the square root of x, that's not going to be very helpful because the square root of 2 is not a number I feel like dealing with. So if you think about it, 4 is the next logical number because the square root of 4 is 2. So that gives me like nice numbers. And then the next one, of course, would be 9 because the square root of 9 is 3. So now we're going to go and we're going to plot these numbers on our graph. So 0, 0, 1, 1, 4, 2, and 9, 3. So before you draw it, though, I want you to watch me because at the very first point, this point right here, at that point, that the curve is vertical. Just at that one instant. And I know it doesn't matter much to you now, but it will matter a lot in calculus. Okay, so let's look at this shape. If you sort of tilt your head to the side, you can see that it sort of looks like a half a parabola, but it's been flipped on its side. Let's think about why this might be. What did we learn in the last section? We learned about inverses, right? So why is it half a parabola on its side? Because y equals the square root of x is the inverse of x squared. So a parabola that would normally look like this is flipped on its side, except for that we don't have the negative part of the parabola. So hence why I put this part, if x is greater than or equal to 0. Okay, let's try some shifting. So the first ones we're going to graph are y equals the square root of x minus 2, and then we'll also do y equals the square root of x plus 1. Okay, and we're going to base these off of our parent graphs. Okay, so all of these points here, they're just going to get moved down 2. So the point that's at 0, 0 will now be at 0, negative 2. And the point that is at 1, 1 will just go down 2. Over 4 will be at 0. And then over 9 will be at 1 instead of at 3. And again, when we draw this, when we started our first point down here, that's going to be just vertical for a second. Oh, I don't really like that. Let me try that again. Oh, wow, I'm really missing. All right, let me try again. Let me get rid of that dot. It's too big. Okay. Much better. Okay, let's take this greenish one. Now all of these points are going to be up 1. So it's always about going back to the parent. So this is going to be y equals the square root of x, but every one is going to go up 1 spot. So instead of being at 0, 0, we'll be at 0, 1. Instead of 1, 1, we'll be at 1, 2, 4, 3, and 9, 4. Okay. All right, I hope it's going okay so far. All right. So these were, of course, vertical shifts. I probably should have said that. And notice where the extra numbers are. They are outside of the square root sign. Outside. Okay. When we come down to these next two, notice that these changes here, these are inside the root sign. Actually. And so these are going to be horizontal shifts. Remember that X is always lie. Very good. I could hear you. It was like I could hear you. I don't think that's the right color. Is that the right color? No, I think it's this one. Okay. So now all of these are going to shift, but remember X is always lie. So this is, that wasn't the right color. This is going to shift left 4, even though you would have thought it would be right. And this one is going to shift right 1. So I'm just going to make myself a note of that. Okay, so the first one, instead of 0, 0, is going to start left 4 spots. And everybody else is just going to follow suit. I missed, but it's pretty close, so I'm just going to have to let it go. Okay, this second one is right 1. So my 0, 0 is going to move over to 1, 0. Everybody's moving over one spot. I feel like Bob Ross. Got that monotone, calm voice. Okay. All right, what do we think? Okay. All right, remember that original point it's vertical there. Okay, so now let's come down to the next page. We got some more stuff going on. Now, if you notice here, I have tables set up, and I did not have tables set up here. These were very minor in the scheme of having to transform a graph, and so I didn't feel like a table was really necessary. But once I get pretty involved, a table is really going to help me. So I'm going to look at this graph, this function here. I have 3 changes. I've got this 1, I've got this 3, and I've got this negative 1/2. So the 1 is going to be my vertical shift. 3, that's my horizontal shift. And do you remember what A does? That's the vertical stretch or compression. In this case, it's going to be a compression. It's also a flip because of that negative. But we're going to take care of this we're going to take care of those two in one step. So the first thing I want you to do is make the table of your parent graph values. So the same exact table that we had right here. Okay, 0, 0, 1, 1, 4, 2, 9, 3. So we're going to write those here. So 0, 0, 1, 1, 4, 2, 9, 3. Okay. This number is a vertical change, and this number is a vertical change. This number is a horizontal change. So this guy will only affect X, but both of these guys will affect Y. Let's start with the X first. So this is X minus 3, but of course we really know that that means right 3. So if you had an X value of 0, let's say, then that would move to the right 3. So even though it says minus 3, you'd really be adding 3. And so that's what we're going to do to all of our X values. So we're going to take each of our X values, and we're going to add 3 to them. So 0 plus 3 is 3, 1 plus 3 is 4, 4 plus 3 is 7, 9 plus 3 is 12. And so now this is my new set of x values. 2 things are happening to y, but you're just going to do it like order of operations. So this is a multiplier and this is addition. So of course you would multiply first. So the first thing we're going to do is multiply all of the y values by -1/2. And I'm just going to write those all down. So 0 times -1/2, 1 times -1/2, and so on. So what do we get for that? 0 times -1/2, well, 0 times anything is 0. 1 times -1/2 is -1/2. 2 times -1/2 is -1. And 3 times -1/2 is -3/2. And then once we get those values, which are here, then we're going to take those and we're going to add 1 to each. And so here I am. I'm telling anyone who's looking that I'm adding 1. So 0 plus 1 is 1. -1/2 plus 1 is +1/2. -1 plus 1 is 0. -3/2 plus 1 is -1/2. And now these are my new y values. So I'm going to go over 3, up 1. Over 4, up 1/2. Over 7, up 0. Over 12, down -1/2, or down 1/2. So what was that? 12. Okay, I'm going to zoom in so I can draw my graph here. Okay. Now, if you don't like the table and you're more comfortable with just working on a parent graph, I don't care at all. You do whatever works best for you. But if your system isn't working, I respectfully request that you consider my system. But, you know, as long as you get the right graph, I don't really care how you get it. Okay, let's try this other one. Okay. So y equals 3 times square root of x plus 2 minus 4. So the transformations are, you know, just different by numbers, but the process will be exactly the same as we did up here in number 3. So really what I want you to do, I want you to start off by making your table of xy numbers for the parent square root of x graph, 0, 0, 1, 1, 4, 2, 9, 3. And then I want you to try to manipulate the numbers on the table based on your equation to get your new x values and your new y values. So what I want you to do is pause the video and see if you can fill out the table. And then when you're done, turn the video back on and you can see if your answers are right. Okay, I hope you didn't cheat and not pause the video and try it yourself. But, you know, there's only so much I can do here. Okay, so this tells me that I'm going to subtract 2 from each x. Now, the logistic problem here is that I have to write any manipulations to x sort of backwards. I have to write right to left. So when you subtract 2 from a number, you know, x minus 2. It's the same as adding a -2, right? So when I made my little notes here of what I was doing to each number, I wrote plus -2. And I just wanted you to know why I did that. So we're going to add -2 to each of these numbers. And then that will give us -2, -1, 2, and 7. And now there's going to have to be 2 changes here to y, because the y's will have to get multiplied by 3 and then subtracted by 4. So first times by 3. So 0 times 3 is 0. 1 times 3 is 3. 6, 9. And then we're going to subtract 4 from all of these. -4, -1, 2, 5. And now these are my new x and y values. Okay, so left 2, down 4. Left 1, down 1. Right 2, up 2. And right 7, up 5. Yeah. It's very different looking when you multiply the square root graph by 3 as opposed to these regular ones up here. Okay, so that was some samples of square root graphs. Now I want to talk about cube roots. Okay, so cube root functions, let's start, instead of cube root, let's start by talking about x cubed. Okay, so right here, y equals x cubed. Okay, so let's get some values here for y equals x cubed. So these are the ones that I like to use, and you, hopefully you remember this from way back when, because we have graphed x cubed before. So if I use these x values and I put it in here for x cubed, then I'll get negative 2 cubed is negative 8, negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is positive 8. So let's look at y equals the cube root of x. Cube root of x and x cubed are what? What are these things? Come on, think about last section. These things are inverses. And what do we know about inverses? Their x's and y's swap. So all of my x values here are going to become my y values over on the inverse. And all of my y values on the original will be my x values on the inverse. Okay, so this right here, these are your parent graph values. Oh, that didn't like that. For the cube root of x. So you're going to base every cube root graph off of this table. So this is the parent table. So let's graph that, see what it looks like. So we have negative 8, negative 2, negative 1, 1, 0, 0, 1, 1, and 8, 2. Oh, that got a little crazy there. Oh, I didn't even have it the right spot anyway. Okay. This is not the easiest thing to draw, but you can watch me draw it, and then you can maybe get some ideas. So I just start from the middle. And remember that this point here, this very original point, when you're drawing your curve off of that point, it's really vertical in that one spot. And it's really important for calculus. That didn't look so good. Let me try that again. There we go. That was a fail. I guess that was better. I don't know. Not my best work. Okay, so there's a cube root of x. All right, let's try some transformations. So now we have a 2 on the outside, a plus 1 on the inside, and a minus 4 on the outside. So this plus 1 on the inside, that's going to change my x values, and I'm going to take all of my x's, and I'm going to subtract 1 from them, or add negative 1, because x's lie. This is going to be a y, so I'm going to times all of my y values by 2, and then after I do that, I will add 4 to the y's. Okay, but first we're starting with our original parent graph table of values. Negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2. So all the y values, we're going to add negative 1 to them. Opposite of what's inside. So that'll be -9, -2, -1, 0, 7. And that's it, because there's only one change. We're not going to do any changes with horizontal stretching or compressing. That would be here. We're not going to do that. Okay, so the first thing we're going to do to our y's is multiply them by 2. So -2 times 2, -4. -2, 0, 2, 4. And then we're going to add the 4 to them. I'm sorry, why did I say add? It's not adding. I've lost my mind. We're subtracting 4. Okay, sorry about that. So -4 minus 4, -8, -6, -4, -2, 0. So now I have my new x's and my new y's. Okay, now I'm going to change the color. How about that purple? Okay, so I have -9, -8, -2, -6, -1, -4, 0, -2, and 7, 0. Okay, so this right here, this point here, that's like my vertex. So I'm going to start there. Oh, see, it wasn't vertical. And starting from the middle helps me. Oh, I missed. Helps me keep my curve vertical at that point. And so you can see that it's stretched vertically. The purple one is stretched vertically from the orange one. You can see that. Okay, so now I want you to try one. So be a good kid and pause the video and see if you can do this next one. And then come back and see if your answers are right. Okay, I hope that you're not cheating. So first, don't forget your parent graph values. Now, they do have this a little bit out of order. This 3, we're used to seeing at the end back here. That's usually where our K number is, but they put it in front now, but it really is the same thing. So you can feel free to just, get rid of that and just move him over to the end if that makes you happy. I would imagine it would probably make most of you happy. So we're going to add 2 to all our x's. So see if you have those numbers. And first, we're going to multiply all our y's by -1/2. -1/2, 0, -1/2, 1. Sorry, -1. And then add the 3. Now you have to graph these points, so when I'm graphing, I would prefer a mixed number because that's just easier to graph for me. So we have our new x and y values. So we have -6, 4. Oh, that's 5. 1, 3.5. 2, 3. 3, 2.5. And 10, 2. This is going to be harder to draw, I can tell you that. So here's the vertex right here. So we're going to try to go vertical out. Although, it's kind of hard because this is one's tight. So try to go vertical off of here. See, I can only go right to left for a little bit before I gotta go the other way. That's a little bumpy, but okay. Last type. This one, look at this one. What's the problem here? Didn't I just say we're not going to have any horizontal compressions or stretches? And who's sitting there next to X? There's a 9 there. I know what you're thinking. She lied. Well, only kind of, sort of. So what we're going to do is we're actually going to rewrite this in such a way that this 9 is actually going to turn into a number that's on the outside. So if I take this y equals square root of 9x plus 18, you can probably see that I can factor out a 9 and get 9 parentheses x plus 2, and all of that is underneath the square root. But can't we take the square root of 9? I mean, we can. We can't do it up in this first step because of this addition here. So you can't take anything out of the square root if there's addition. But now it's multiplication. So you can take the square root of 9 and get 3. And now you have this equation, which is a little bit easier to deal with. So this is back to a square root, though, so be careful. It's not a cube root. So here are original square root parent graph values. And what are we going to do to our x's? We're going to subtract 2 from them, or add -2. And what are we going to do to our y's? We're going to multiply them all by 3 because of the 3 out front. And then I'll get 0, 3, 6, 9. And now I have my new values. So I have -2, 0. -1, 3. 2, 6. And 7, 9. I think that's right. Yeah. And remember that when you're coming off of that original point, you got to start vertical. Okay, so now I want you to try this one. This next one is a cube root, but same idea. You can factor out a number and change the way it looks a little bit. So why don't you see if you can change the way this looks to make it easier to graph, and then pause the video, give yourself a minute, see what you come up with, and then come back and check. Okay, so I factored an 8 out just underneath the cube root and got 8 times x plus 4. And the reason that's good is because there is a cube root of 8, it's 2. So I can take the cube root of 8 and make it a 2 on the outside. Now this is a cube root, so I'm going to have my initial values for my cube root function. I'm going to add -4 to all of my x's. I'm going to do that arithmetic. And then I have 2 things I have to do to the y's. The first is multiply them all by 2. And then subtract. Oh, sorry. Wait, I didn't get the answer yet. Sorry. We're going to times them all by 2. There's the arithmetic. Then we're going to subtract 2 from each of them. And I'm going to do some more arithmetic. So now we have our new values. My new x values, my new y values. I have no idea what is under this little box. I guess it's my whole graph. I don't know. Oh, yeah, I guess. Okay. I think I forgot to clear the graph, so I just covered the whole thing. But you have a graph on yours. So here we have our -12, 8, our -5, -4, -4, -2, -3, 0, 4, 2. And remember, at the center, you want to try to make it vertical through that point, because that's how it really is. And I know you don't care now, but when is it going to matter? That's right, calculus. See, I'm prepping you. Okay, so I hope that was helpful. This is the last section in Chapter 6. Isn't that exciting? And so please try the homework problems. Make sure you're using graph paper. If you submit to me graphs that are not on graph paper, I'm going to lose my mind. So you can do it in Notability right here. Remember, you can change the paper by going to the little, this little wrench and choose paper, and you have all the papers you can choose. You can choose your size grid you want. How I did it on mine was I used this little plus here, and I did a sticky, and then I used a grid, and then see the little grid, and you can stretch it, and then, but see the squares are bigger here, so you can click paper here. You can change the size of the squares. You can change the color. You know, it's kind of fun. Oh, the brown is gross, but the rest of it's kind of fun. So, or of course you can print graph paper. A good website to print graph paper is called mathbits.com, and they have so many different graph papers you can print. It's kind of ridiculous. So that's another thought. So remember, you must use graph paper. Okay.